Welcome to the week 11 live interactive session for this NPTEL course, Transition Metal Organometallic Chemistry Principle to Application. So we have completed last week the week 10 content and the question and answer discussion session. Now we move to the our next week, that is the week 11, and the last week we have started the discussion on the transition metal carbonyl compound, their bonding and their properties and their reactions. After that we move to the another system of the organometallic compound, that is the transition metal olefin compound or complexes. That means transition metal is bound to a olefin in a eta 2 or eta 4 manner. So in this week, that is the week 11, so the second last week, we have seen several examples of preparation for the preparation of transition metal olefin complexes. We have seen their bonding properties and finally their reactivity studies. So before starting the today's question answer series, this is the all which we have seen in this, and after the olefin system, that is the we move to the another olefin system, that is the conjugated olefin system, that is butadiene or cyclobutadiene type of system at the end of this course, at this week content. So we will discuss everything, the most important thing of this week content through the help of questions, and after the question, like the previous, we will point it out the important topics from this week, and then we will summarize the week content. So another 1 or 2 minutes I will wait for the participant, and after that we will start this today's session.
Good afternoon, sir.
Good afternoon. So we will wait for another 1 minute or 2 minutes, then we will start the discussion. By the time, if you have any doubt regarding this week content, we can discuss.
Sir, actually, one more doubt I have, like not with the course. I just want to say one thing, like I actually received one mail regarding that my hall ticket has come, but I am unable to access the hall ticket, sir.
Oh.
Oh. Yes, sir.
Exam is, so that is technical issue, na? You can email that NPTEL office.
Okay, sir. Like in the portal, I am unable to like search like any place, like any admit condition release, like I am unable to access it. So that to reach out to NPTEL office, you're saying.
Yes. So
Okay,
best
sir.
way to, you can contact that NPTEL office, and then you will get the thing.
Yes, sir. You are saying exam is on 26th.
Yeah,
Okay, sir.
we have enough time, about 20 days.
Yes, sir. Okay. And I need to keep revising other things as well.
Is there any announcement whether the ticket has been released?
Once again, let me just check, sir. Yes, sir. I got like that announcements.
Okay. Okay, it's so there is I think there will be some support team for this email.
Yes, sir.
Okay. Email you know the email of that office?
No, sir. Not quite aware about it.
1 minute.
Yeah.
Okay. Here nothing is written about this. It is all about the courses and all. So it is best way to write. I will if I can get it, I will share that email address, or you can find, or you can email to this. Actually, this is an email address: noc25 underscore cuy65 at the rate. I think I have it.
Just a minute. Let's note it down. NC 25 underscore CY65. Yes, sir. NOC 25 underscore CY65 at the rate of.
1 minute.
Yeah.
I think it is. I am not sure about this email. So you guys search. You can search in the portal or see, or I will tell you in the next video, next session. Exam is
Yeah. Okay, sir. Yeah. Okay, sir.
okay. It is not in the portal. Nothing written about the where to contract and all. It,
Yes, sir. Fine.
so about this is your course code, huh? NOC 25 CY 65.
Yes, sir. That's my course code. I think.
When you write an email, you can mention this course code
Yes, sir.
so that they can get everything with your some number could be there, na your email address or anything else. So, should be anything of support. No, here yes, Swam helpline or support. Hmm. Here you can see that email address.
Yes,
support
sir.
further@nptel.iitam.ac.in.
Just a minute, sir.
You can see my screen, right?
Yes, sir. And so I'm just writing it down. Support at the rate of nptel.iotm.ac. Yes, sir. Okay.
You write a mail to them, whatever your query regarding the examination, and
Yes, sir.
mention that course code number.
Yes, sir. NSC 25 underscore CY65.
And with the course name. Then
Yes, sir.
they will uh, they will like tell you about the any kind of exam related problem or which you are facing.
Yes, sir.
Okay, let's start this session.
Yes, sir. We can start.
So welcome again. This transition metal organometallic chemistry principle to application live interactive session for the week 11 content. So again I am summarizing that from the week 11 we have moved to our another ligand system, that is the transition metal olefin system. And olefin bound to the metal in eta 2, or if it is olefin double bond is more than 1, it can be eta 4 also for the conjugated olefin. And we have seen the various method of preparation for that metal olefin complexes. After that we seen the bonding properties, how transition metal is bonded to the olefin, and finally we have seen the some reactivity studies of this olefin. So with the overall outline, we notice that transition metal olefin complexes are stable and more stable, you can say more stable for the late transition metal, that is the group 4D and 5D transition metal, whereas it is very less stable corresponding to the early transition metal like nickel, iron,
Yes, sir.
cobalt, like this. Because of what they are less stable, we can also explain this from their bonding properties. So let's start the, so with that is the overall content. So we will discuss each and everything through the question and answer. First question is, which of the following statements which of the following statements correctly describe the bonding in transition metal olefin complexes? Option A, the olefin donates electron density via its pi orbital to the metal as a sigma donation. The metal donates back into the olefin's pi star orbital, that is pi back donation. Both interactions strengthen the CC bond. Pi back donation reduces the bond order of the coordinated CC bond.
I can say option A is the one answer.
Again, I am saying the question, which of the following statement or statements correctly
Yes, sir. That's
describe
what.
the bonding in the transition metal olefin complexes?
That's what, sir. First I'm saying option A might be an answer.
Yes, so
I'm keeping
option
first
A
in.
is one of the answer.
Yeah, the metal factors olefins, pi star orbital,
What
pi
can be the other?
more interaction to the CC bond. Pi by convention reduces the bond of the one holding the CC bond. I okay. Metal is again metal is metal settlement. Yes, yes, yes. So can D be the answer?
Okay, option D is one of the answer. Then
Then
these two only, or any other answer is possible?
still figuring out, sir. Then this is one more nothing. D is also option, sir. A, B, D.
Yes. So here the three options are correct. So says that which describes the bonding in transition metal olefin complexes. So first of all, when the olefin donates electron via the pi orbital as a sigma
Yes, sir.
donation, and the metal donates its electron in the pi, is option A and B, both are correct. And when the metal donates the electron to the pi star orbital, that means pi star is getting populated, and because of the pi star population, the bond order between the C and C, that is the CC double bond order, will be
Yes, sir.
decreases. And
Yes, sir.
the same thing we see in the,
Carbonyl
it is equivalent to
to
CO.
olefin.
Oh, like the carbonyl. When transition metal
So,
donates more electron, more back bonding, which also decrease the bond order of the carbonyl. And bond order decrease means decrease in
yes, sir. So bond order decreases means decrease in stretching frequency.
reaching decrease in IR stretching frequency, or
Yes, sir.
decreasing the
Stretching frequency is CC.
CO or CC bond strength. Bond
Yes, sir.
strength also decreases.
Decreases.
Okay, so here option A, B, and D will be the correct answer. Why are early transition metals generally poor at forming the stable olefin complexes? Early transition metals form stable complexes, but they are not very stable. Like nickel, a very common example, nickel COD whole 2. This complex is formed as an early transition metal, but form this is not stable. What does it mean by cord?
I understand, sir. Like chord. Like, are you writing something in the screen? Ah, okay, okay. Oh, now it's okay, okay, sir. I think that time slide didn't change. Now only it got changed. Early transition metal generally poor forming stable
Why
olefin.
early transition metals generally poor at forming stable olefin complexes?
Yes, sir. NiCO twice. They have low atom series of pi pair conditions where the oxidation states are too high for body, preferably sigma only ligands. Sir, chord, that's the doubt, sir. Like chord, that's ligand. I'm yet to confirm that.
What will be the answer? So lack of vacant orbital. Option B, they have low electron density, so pi donation is weak. The oxidation state are
No,
too
sir.
high for bonding, or they prefer sigma donor only ligand.
So nickel configuration is like
No,
I
nickel is an example. I am not. Nickel has a no relation with this question. This is an
no, sir. I'm just
example.
finding out the electron density present in nickel. It is electron configuration.
Should,
That is electron configuration is D8S2. That is 10 electrons. So there is so I would say like I won't say like there is low electron density. So I think B is cancelled. And oxidation state, I guess it won't be too high, sir.
no, you don't understand the question. Question say why are
Okay,
early
well,
transition metals generally poor at forming stable olefin complexes. Here we consider the stability.
wait, sir.
The complex should be stable.
Calculation of this for signal demands. Can it be option D?
They prefer sigma donor only ligand.
I think so, sir.
Okay, so here the question, let's say, so this is not no relation with this question. Question is independent on this. So this says that why are early transition metal means nickel, iron, cobalt,
Nickel, copper, zinc.
copper, like this.
3D metals.
3D metals. So these metals generally poured in forming stable olefin complexes. We are not talking about the other complexes, we are talking about the only olefin complexes. So for the olefin complexes, this metal doesn't favor to form the olefin complexes. What is the reason for it? That is the question. Why this 3D metal doesn't favor in forming the olefin complexes? What the reason? What the thing? So now the question is, they lack vacant orbital? No, they have enough vacant orbital. They have d orbitals. They have low electron density, so pi donation is weak.
No, sir. The oxygen related to electron only the special sigma demands.
Low electron density, so donation is weak. Oxygen states are too high for bonding, and they prefer the sigma donor ligand only. So for the early transition metal, their size is small and their electron is tightly bounded for the, so, and their pi donation tendency is less because they have small size and electron is strongly bonded until unless they have a strong sigma donor ligand. And so that, and most of the complexes prefers to stable in the high oxidation state, most of the metal center. So that's why the pi donation is not possible. That's why they doesn't favor the olefin complexes, but they favor carbonyl complexes because
Sir.
carbonyl is more stronger pi sigma donor
Pi
compared to
X.
the
Okay, sir.
olefin.
Olefin.
That's why is prefer, we can form complexes with the carbonyl but not with the olefin. The nickel
Olefin.
quad is another example where it form complexes which as an early transition metal as an olefin quad is cyclooctadiene
Ah, yes, sir. It is a ligand will take in the form of a tub shaped.
like this. Like this it will donate to the metal. Is it visible?
No, sir. You're writing something in the screen.
Now
No, sir. Ah, yeah, yeah, yeah. Now I got, yeah. Yes, sir.
okay. So this is the, so here the option is there because of their low electron density, they are on the metal center, their pi donation is weak. That's why as the sigma donation is also not very strong for the olefin, that's why its formation of the olefin complexes for the early transition metal is less.
It is pi donation is weak.
Yes, so option
Okay.
B will be the correct answer for this one.
Yes, sir.
The next question will be, which factor introduces the deviation from planarity in an olefin complex toward a metallocyclopropane structure? Which factor introduces the deviation from planarity in a olefin toward metallocyclopropane structure. So what does it mean? So we have metal is coordinated to the olefin. So this is eta 2 mode of coordination. So after that it will change to metallocyclopropane. So that means this. Okay, this is the olefin.
Once a slide is not loaded, sir.
Now
No,
is it
sir, no, not yet.
what is happening? Now it is fine.
Yes, something is loading, sir.
There's no issue with the internet.
Yes, maybe it's an issue from my end, sir. Maybe. Yes, sir. Now it came. Yeah. Which factor induces deviation from planarity in an olefin complex through a metallocyclopropane structure? Strong pi-pi donation. Okay, large ligand angle, weak metal olefin interaction.
So this one is metal the olefin and this one is metal cyclopropane.
Yes, sir.
So what is the difference between these two structures? Question is which factor introduces the deviation from planarity in the olefin complex towards cyclopropane? That means during the conversion of olefin to cyclopropane.
Yes, metallocyclopropane.
Hmm.
What is the deviation which happens? What is the factor which induces
Which
deviation?
factor introduce the deviation?
Strong sigma donation from metal to ligand, no, not possible. Strong pi-pi donation from metal to ligand, no. Large ligand cone angle, weak metal olefin interaction. Is it option D, sir?
So if it is option D, weak metal olefin interaction, that means if the interaction is so weak that olefin complex cannot be converted to the cyclopropane. So how a olefin complex converting to a metallocyclopropane?
Okay, wait. Large ligand cone angle, strong pi-pi donation repeated. Which factor induces deviation from polarity in an olefin complex towards a metallocyclopropane structure?
So here
B.
Hmm. So here explain. So here
Yes.
we have metal olefin complex. That means olefin is bounded to the metal center. Now
Yes, sir.
what in a sigma bonding fashion. Now what metal will do? Metal also has the electron. Metal will donate each electron to the pi star orbital of the
Of the olefin. Pi star orbital of olefin.
pi star orbital of the olefin. So so metal has 2 pi orbital. So now you have the 2 pi orbital. It will be like this. Now if metal donates electron to the pi star orbital of the olefin, like so here we have one electron, here also we have one electron. So here it will be 1 2 3 4, or 4 is completed for the olefin. Okay, C C. So when the extra electron is coming to the metal, let's say we have a metal electron, so that will donate to the electron to the pi star orbital. So as the population of the pi star increases, so that will, so C is a bond order.
So writing something.
Yes, it is not
No,
coming.
not visible for me, sir. Now only is visible. Okay, now only got
It
it,
will
sir.
come. Bond order
Yes,
of Cc decreases.
yes, sir.
Bond order of Cc decreases because of
Upon
the
back donation.
upon pi black donation, which will go to the pi, and this will be pi star.
Yes, sir.
This will be, goes to the pi star. So this will decreases. So as the bond order decreases, so double bond, so one of the double bond will be open up, and that will be converted to a Cc single bond. So that elongation will be so long because of the population in the pi star, double bond will be converted to the single bond. Now double bond, what was the hybridization? It was sp2.
SP2.
Now because of the single bond character, it will be sp3. So you all know that sp3 hybridization, it is, we should not be any planar. So it is, sp2 is planar, and this will be like tetrahedral. sp3 hybridization because of the Cc double bond. So now coming back to the question, that deviation from the polarity. So deviation from the polarity happens because of the metal to pi back donation to the metal, by back donation of the metal electron to the pi star orbital of the olefin, which decreases the Cc bond order, and that's why it converted to double bond sp2 to single bond sp3. That's why it loses the polarity. So main reason is the strong pi back donation from metal to ligand, so that is
Okay.
converted to eta 2 mode of olefin to metal
Eta 1.
cyclopropane. So
Yes, sir.
option B will be the correct answer.
Yes, sir. Okay, sir. Got it. So cone angle won't be involved here, I suppose, because there is no cone angle concept involved.
Hmm.
Okay, sir.
Next is question number 4, comparing isolated versus conjugated diolefin. Which statement are true? So conjugated, comparing isolated versus conjugated diolefin complexes, which statements are true? So conjugated means we have like this.
Alternate double single bonds, like say 1,3 butadiene.
So that means 1,3-butadiene, and
Yes,
here
sir.
you have like this, that's are isolated,
Isolated
this
double
is
bonds.
isolated, and this is conjugated.
Conjugated.
Option 1 is
Option 1
conjugated
can be answer. Conjugated
conjugated
diolefin.
diolefin show delocalization of the pi systems interacting with the metal. Unconjugated diolefin behave like two separate monoolefins. Monoolefins complexes. Both types exhibit identical Cc bond length, and conjugation enhance the extent of metal ligand back bonding.
So one thing I can say, like when butadiene is reacted with metal, what happens is when metal coordinates with the 1,3 butadiene, then this it converts to eta 4. It shows eta 4.
Hmm.
Eta 4 interaction. So I would say one option A can be one answer.
Hmm.
The unconjugated olefins have to separate monoolefin complexes. Sir, I have a doubt. Like unconjugated olefins, like whenever they react with metal, they actually form a ring type structure around the metal, right?
So option A is one of the answer. Okay.
Yes, sir.
Now coming back to the option B. So unconjugated diolefin behave like two separate monoolefin complex. So if we consider this, so there is no conjugation between these two
No, sir.
olefin. So that's why this terminal and this terminal behaves independently.
Yes,
There is
sir.
no interaction between these two. That's why it will behave as a two separate monoolefin,
Yes, sir.
just where connected as CH2. Okay, so B can option be also an answer, and that both
Yes, sir.
types exhibit the identical CC bond length. Obviously not, because
No, sir.
because
The bond elongation will take place, right? As a result,
because
stretching
for
frequency.
the
Because,
conjugated olefin, let's say we have this. So you can say this double bond is here, and also this double bond can be here. Both are
yeah,
same. That
same.
means this for the conjugated olefin, the because of the conjugation, all CC bonds are equal length because of the
Yes, sir.
conjugation. So,
Conjugating match
so
like
both types cannot same if the same. Whereas if there
yes,
is
sir.
no conjugation, the all CC bond length cannot be same.
Yes, sir.
Okay. So here,
I think what I am saying is unconjugated dolphins will be as such. They won't be showing anything.
they will be not identical.
Yes, sir.
Let's. So here, if you have a like this, let's say if I name A, B, C, D, and if we consider the distance CC bond distance CA CB equals to distance of CB CC equal to distance of CD and CC. So these all three AB, BC and CD, these three odd bonds are equal because of the conjugation.
Yes, sir.
But if we have the isolated olefin like this,
Yes, sir.
so then this bond length this will be a smaller when the olefin is present, and internal CC bond will be longer. Is it visible?
Could you repeat, sir? Like for isolated double bonds?
For isolated double bond,
Yes, sir.
the terminal olefin in this
Yes, sir.
structure, and the internal are CC single bond. So CC single bond will be longer, and terminal double bond will be, or olefin.
Yeah, that will be shorter. You're saying terminal double bond will be shorter, whereas the
Because
internal carbon-carbon bond will be longer.
so here all the bond orders are not equal
Not the same. Yeah, they're not the same.
because there is no conjugation.
Yes, sir. That is ruled out, sir. Option C is ruled out.
And
Conjugate enhances the extent of.
conjugation enhances the extent of metal ligand back bonding. Is it correct?
No, sir.
Why not?
Sir, one second. Just let me just think, sir. Yes, I think it should enhance the metallic and bonding. Like say for
Why?
butadiene.
Because if you have the extent of conjugation, metal ligand back bonding happens from metal to pi star orbital.
Yes, sir,
So
orbital.
if your metal is more conjugated, then this pi orbital will also be stabilized. The conjugation brings the stability. So
Yes,
if
sir.
pi orbital will be stabilized, then your pi star will also be stabilized.
Yes, sir.
And
Got it.
then the back donation will be favored. Okay. So
Yes,
this
sir.
will
Okay,
be
got it.
also another correct answer. So option A, B and D, both three are correct except option C. Got the question correctly?
Yes, sir. Got it.
Next question is, there are two three question based on this reaction type. predict the product of the reaction. That means this is the method for preparation of transition metal olefin complexes. Preparative method. One of the preparative method. So what will be the answer?
Okay, sir. Is equal to Is it option B, sir?
Hmm?
Option B?
Option B and option C. The option, so here you can see that we have used a organoaluminium compound. What is the
Okay.
role of it?
That I'm not sure, sir.
Last class we also explained during the preparation of carbonyl compound,
Yeah.
metal transition metal carbonyl. The role of this kind of, what is the role of NaHg?
Reducing agent, sir.
So like this also compound act as a reducing agent. Reducing agent. So
Okay,
because
sir.
of this we have nickel chloride. That means nickel in plus 2 oxidation state. Because of this plus 2 oxidation state we are using a organoaluminium compound which will reduce the nickel from plus 2 to nickel 0. So that is sure. So for that reason we can say that option A and option D cannot be your answer.
Yes, sir.
Okay, so from the last week knowledge, if you don't know anything from this preparation, you can clearly say that option A and option D cannot be your answer,
Yes, sir.
because here nickel in is plus 2, another is plus 3 oxidation state, which is not possible.
Yes, sir.
Clear?
Yes, sir.
Okay. Another thing, this olefin is also in a trans fashion, and here in option B you can see that both olefin are a
Cis fashion.
cis fashion.
Okay. So which means
that
B
is
is omitted, you are saying.
that is less preferable for this, and it will undergo a cyclization type reaction, and it will give the option number
Option number
C,
C.
when all all olefin are trans to each other. All olefin are trans to each
Wants
other.
to each other.
Okay, so here, so just by looking at the question you can eliminate two options, option A and option D, because we know that when preparation of olefin, preparation of metal carbonyl complexes, if you use sodium amalgam or a triethyl organoaluminium complex compound, this will reduce the metal center to the from positive to, it will reduce the metal center. So because of this we will generate this.
Okay, sir. Got it.
So option C will be the right answer.
Yes, sir.
Next question, what will happen if we react this compound, that is which we prepared in the last reaction, by reacting with nickel and triethyl or alkyl aluminium with the olefin or butadiene. What will happen if you react with C8H12? What is CH812?
Cyclooctatetraene, a tub shaped, yeah. That is COD.
This is C8H12. So here we have a double bond. This is called COD, cyclooctadiene, cyclooctadiene, COD ligand. So if you react with this, what will happen?
So now currently, as you can see, the reactant nickel is reacting with like two or three olefins. Like it's coordinated with three olefins. Like if this comes into picture, then I guess nickel will coordinate. Like nickel will coordinate at least with one olefin and then with two olefins with CH12. So I guess ideally maybe option D might be the answer. I suppose.
Here this will form and then it will complex will break to give, because this is only stable in the excess of
Yes, sir.
cord ligand. So all these olefin moiety will remove and it will bind with the two of the nickel cord, two of
No,
the
but sir, how it is possible? It's not. Is it given excess?
yes, we are this because of the stability. This will become more stable when because of the reaction condition.
So we assume this is excess.
Yes, even we have
I
seen,
mean,
we go through it, we'll go through it during the last discussion.
yeah, yeah, fine.
Some ethylene molecule are only stable when they are kept in a ethylene in presence of a ethylene gas. In
Yes.
that condition, that complexes are only stable. Okay, so when you remove it from the ethylene gas or ethylene vapor, it will decompose. So this is the complexes which can be stabilized under this formation, and after some time it will react and it will decompose, because as I showed in that first question or second question, that first row transition metal olefin complexes are not very stable. Okay, so option B will be the right answer. Next question is another, predict the product of the reaction. So we have IR, iridium, ClCO, PPH3 whole 2, and we have an R2C double bond Cr2, an olefin. And you can say there is an this. What is it called?
Equilibrium.
Equilibrium. So which will be equilibrium with this? Equilibrium means this reaction is a reversible reaction.
Yes, sir. Is equal IR is equal to like IR 7 plus 2 9 plus 1 10 10 plus 2 12 plus 4 15 plus 10. Sir, the first of all, this molecule is 16 electron complex, right?
Hmm.
So it needs 2 more electrons such that it becomes 18 electron complex.
Hmm.
So I think option A can be one option.
Hmm.
2 plus 2 1
So
0 2
here
plus
option
2
A
plus
is the correct answer. So one thing you can see that this compound may undergo the oxidative addition also, but here instead of oxidative addition, in presence of ethylene molecule, it undergo the eta 2 mode of binding.
yes, sir.
Eta 2 mode of binding, and here complex iridium is plus 1 oxidation state, and after the formation of the ethylene complex with the ethylene, it is or olefin, it is also in plus 1 oxidation state. But if it goes to the other mode of binding like this or like this, it will be oxidatively oxidative addition.
Yes, sir.
Oxidative addition, and the charge is changed to plus 3.
Plus
Here
3.
not plus 3, here it is plus 3. So here this possibility is not happening, so it will be option A, where this is reversibly bind with the ethylene moiety, and this is only formed in presence of this. Until you remove this source, then immediately it will decompose and goes back to iridium ClCO PPH3 whole 2. This form.
That is, you are saying oxidative addition is not possible in this case. But if in case you remove one ligand like carbonyl ligand, then it can undergo oxidative addition.
Huh.
Okay, sir. Or maybe PPS3.
Hmm.
Fine, sir. Because I also say having one same dot like oxidative addition because 16 electrons, so maybe oxidative addition can occur, I thought.
Huh.
So,
So oxidative addition will not happen like here. See here what will happen, here you will have a eta 2, that is sidewise mode of binding, eta 2 mode of binding, that will be neutral, and iridium will be in same oxidation state. It is a plus 1. Oxidation
yes, sir.
state will not change.
Yes, sir. But upon further reaction with the product, then what happens is it will change to a ring form.
If we react further or under forcing condition, it
Like
will
maybe under
form
heat
a,
conditions or
yes,
light
it
conditions.
will form a this cyclopropane type of ring, and
Yes,
finally it will break to this mode, that is option number C.
yes, sir.
uh, Next is the new CC stretching frequency of the free ethylene moiety is. This is another important question, because when we are talking about the ethylene moiety, molecule in a complex formation like Jayce's salt, K PT
KPTCl3, then C2H4.
CH3 eta 2 C2H4. Okay, this one, right?
Still not visible, sir.
KPTCl3 eta 2 C2H4.
Ah, yes, sir. Yeah, right. PTCl3, sir. PT. Platinum, then 3Cl.
CL3 PT platinum.
Yes, sir.
This is Jayce's salt.
Yeah.
So what will happen? The new CO stretching frequency in the free olefin moiety. So when we will determine the olefin moiety, so what will be the free olefin? Free olefin means only C double bond C. This. What will happen? What is the free ethylene moiety?
Is it 1623, sir?
Is it 1623? So 1623 will be the correct answer.
Yes, sir.
So what will happen to this complex? It is more than 1623 or less than 1623?
Platinum is also a nickel condition. Yes, sir. Like since PT can like if it coordinates with platinum, what happens is it can undergo back donation, right? So which means a chance that it can decrease. Like stretching frequency can decrease.
Yes. So for the metal olefin
So it
complexes,
will, it
then
will drop down to 1523.
ha,
Okay, sir.
no exact value I can say, but there is a few example where you can see the exact value of this. So what will happen? Generally, you can say that when we will introduce this ethylene molecule in a as a ligand to eta 2 mode of bonding, then what will happen, this will undergo the back donation from metal to ligand, and that electron will be will came in the 5 star orbital, which will decrease the bond order, and that decrease is also decrease the stretching frequency of CC bond. So whenever it combine with the metal, that will decrease from the ideal CC stretching frequency or free CC stretching frequency. Okay.
Yes, sir.
Next question is question number 9. Which changes occur when 1,3-butadiene coordinates to a metal as beta 4 diolefin or diene? Option A, internal CC bond shorten relative to the terminal one. All CC bond length become nearly equal. Electron density delocalize over all 4 carbon. The metal interacts mainly with the terminal carbon.
Which changes in material use the metal is informed. Option C can be one right answer, sir.
Okay.
Yes, in all CC bonds become known. Metal interacts mainly with terminal carbons now. Shortens 0 to terminal. Then all CC bond lengths become nearly equal. Option B.
Option B. Okay.
Metal interacts mainly. I guess this is the answer, sir. B and C.
True only.
Let me again verify it. Internal CC bond shortens related to terminal ones. Internal CC bonds. Metal interacts mainly with terminal carbons. Yes, I think these two will be there because it's a 1,3-butadiene is conjugated, right? So I think all the CC bonds lengths are nearly equal.
Yes. So here that because 1,3-butadiene is, so this will, when binding as a eta 4 diene, that means this. Okay.
Oh.
Is it visible?
Yes, sir, visible.
Like this way. So because of the conjugation, it will be all CC bond length will be equal, and electron density also delocalized over all 4 carbon atoms. This is eta 4 bonding. So option B and C will be the correct answer for this question. Next, for a D8 metal center like platinum, to an olefin, which metal orbital primarily interact with the olefin pi star orbital during pi back donation.
D8 metal center between different which
For a
metal
D8 metal center like
pi star
platinum 2 with nickel palladium platinum bound to an olefin, which metal orbital primarily interact with the olefin pi star orbital during pi back donation.
So is it dx minus y square?
Okay, so let me see. So we have olefin.
Yes, sir.
So let's say butadiene. Butadiene. So butadiene have two olefin. So how many molecular orbital will be there? How many?
4. Psi 4.
Huh. So that will be four orbital will be there.
Yes, sir. Yeah.
So first will be this
Yes,
all
sir. First, there
orbital.
won't be any nodes.
Huh. So all will be on the same side,
Yes, sir.
and the second will be there will be one node,
One node. Yes, sir.
and third will be how many node?
There will be two nodes.
And the fourth will be,
Three nodes.
so this will be like this. Okay, so this is the four orbital. So when it interact with the metal, so how many d orbital are there? D z square, d x square minus y square, d xy, d xz, and d yz.
Why is it?
So in between this, which one form the sigma bond?
dx dy is from sigma bond, sir.
Dxz dyz form sigma bond. How?
No, sir. Dxy.
Dxz is this, and yz will be this. So this is the, so this is the orbital lobe in between the axis. So when the lobe of the orbital are in between the axis, they cannot form a sigma bond. Not form.
Okay. They're between the axis, sir.
So if for the dz square,
d z square dx minus y minus y square, sir.
Huh. So here the lobe is in between in this along the axis. Also, if you draw the d x square minus y square, so that's along the axis. So because of that, these two can form the sigma bond. And what will be the dx square minus dxy? Dxy is like the perpendicular to the yz plane. So this also can form a delta type of interaction, kind of sigma bond. And this yz and xz are only capable of forming the pi bond, because the symmetry is matching with the pi orbital. I will show you the diagram. I will not draw correctly, but this. So there, this is the sigma bond. These two are capable of pi bond, and these are not possible any bonding, remain as vacant, because these all same phase, and here you can see this will be same phase and this will be same phase. So this can directly interact with this, and here one phase is same, another phase is opposite. So here like the yz and xz, where one has the same phase, another has a opposite phase, that can interact with the pi fashion. So dx square minus y square and dz square, whose lobes are along the axis, they can form the only sigma bond, whereas dxz and dyz, which lobe are in between the axis, they can form the pi bond, and dxy are capable of forming the delta type of interaction.
Yes, sir.
Here option number pi interaction is observed for
dx dyz.
dxz and dyz.
See.
The sigma interaction dx square minus y square and dz square,
Yes,
and s orbital of d of the d metal, the s orbital is does not participate in the interaction. They are so inside, or the last s electron is already removed. They doesn't participate in the interaction. Next is, this question is an interesting question. The two complexes, so there is a rhodium complexes we have, and both are 16 electron complexes. First complex is rhodium Cl C2H4 PPH3 whole twice, and second complex is rhodium Cl CO PPH3 whole twice. So both the complexes are same. So we have just different pi acceptor ligand. First is ethylene molecule and second is the carbonyl molecule. The question say the IR spectrum of B, that is the carbonyl, show a strong absorption and 1970 center inverse. What happened to the new CO band if one ethylene in A replace CO in B? What happened?
Just a minute, sir. See it on explore replaced by urban. Two electrons, electrons. So I guess it will be unchanged. No.
The question is basically saying that if the rhodium Cl carbonyl compound CO stretching frequency appears at 1970 centimeter inverse, so what will happen to the ethylene stretching frequency? Very simple, think in that way, don't replace nothing because both are different compound. Okay, so instead of carbonyl, if we have a ethylene molecule, what will happen? So if we compare, so here the carbonyl stretching frequency, arises from the pi back bonding, the only thing. Okay, so pi back bonding means the property of the pi acceptor property of the ligand. Here which is our ligand? Here we have the carbonyl, we have the ethylene. So which one is better pi acceptor?
C2H4.
Huh. C2H4 better pi acceptor.
Yes, sir.
Carbonyl will be better pi acceptor, no? Compared to ethylene.
Mm. Yes, sir. Okay, fine. Okay, sir. I'm not sure about it. This question.
So
Sir,
it will
you're
be,
doing week 11 assignment, right?
huh?
Week 11 assignment. Am I right?
No, no, not week 11. It's just combining the two questions of week 10 and week 11.
Week 10 and week
Yes,
11.
week obviously week 11 because we are discussing everything on week 11.
But sir, questions which are given to me is not matching, sir.
Huh?
No, whatever questions you're discussing, it's not matching with the ones which is there in my portal.
No, no. Portal. See, these questions are not the same which are there in the portal.
Okay, sir.
If the portal question are same, then why need to discuss this? We will already get the answer there. Portal
Fine.
question is different question from this. Because if I discuss all the question right now, we will just put the tick 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 over there and get the full marks. That assignment is also evaluating, na?
Yes, sir. Yeah.
So this question is different from the portal assignment. So portal assignment question is different, and this will be different from the portal assignment. This will be similar to that of the portal assignment.
Yes, sir. Okay.
The main top motive is to get the concept of this week cleared through the problem discussion, to discuss the problem.
Okay, sir. I'm not sure about this answer, sir.
So yeah, this question
Oil
is very
trouble.
simple question. So this is like when we replace a weak pi acceptor ligand, so staging frequency will also be, the CO will be more pi acceptor compared to the ethylene. So the pi acceptance property will be significantly decreased. So if the pi acceptance property decrease, the staging frequency will be increases. So this question is a little bit tricky. That means it's shifted to the higher frequency region. This is a little bit tricky question, or you can say like this. So let me if we discuss this. So if we have a both the thing, if we have a CO, if C triple bond O, if you have a ethylene, so this is strong strong pi strong pi acceptor, and we have a CC. CC is a stronger, we can say stronger pi acceptor compared to CC. So 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 as the pi acceptance decreases, so if we remove the CO, the pi acceptor will be less. So pi acceptor will be less means switching frequency of these will increase.
The stretching frequency should decrease, right?
CO will be strongly pi acceptor ligand. So if we bind it to the metal, because of the strong pi acceptor property of the CO, this will be double bonded. So this frequency will be decreased.
Your bond order will decrease, you're saying.
And when it is CO, this pi acceptance will be less. So thus this decrease will be also less. It says
So,
basically that when we have a CO ligand, when it is bind to the metal, the stretching frequency of the carbonyl decreases.
decreases,
This
yeah.
decrease is less compared to that when you have a C double bond C.
Olefin, okay, sir.
Olefin, because its pi acceptance is less.
Yes, sir.
Okay, so with this I think completed most of the questions,
Yes, sir. Fine, sir.
and that one important, there is a trend, that's I am saying here. Here you can see, you can see.
Yes, sir.
So we have the silver complexes where new CO appears at new CC appears at 1584. So when we introduce a carbonyl group, this option number, this compound number 2, in the rhenium complex,
Yes, sir.
this one. So then what will happen? This one.
Okay,
Then
sir. Yeah.
you can see there is a decrease of stretching frequency, because carbonyl here act as a stronger pi acceptor compared to the ethylene.
Yes, sir.
Because of this, the stretching frequency of CC bond will decrease.
Decrease.
Another is, you can several iron complexes, and here in the JC salt KPTCl3, you can see also that this is 1516. So whenever we have the free CH2H4, we have 1623, 1623, and whenever the ethylene bound to all the metal, the stretching frequency decreases. Correct?
Yes, sir.
Okay. Another important question is this. This question is also important from the reaction type, because here is the an example of formation of olefin complex. So this is a CH3 CH CH3, that means a propane. So this is a sigma alkane complexes. So this hydrogen is acidic, or it can release. So here CPH3 plus, so which will take up this proton should become CHPH3 and it will generate the olefin complex. This is one of the important example. So this question can also be asked, what will happen when this react with this? This. Another important method for preparation of these complexes is the co-condensation method. This method is also important, but this method has several limitations. What is the limitation? Because this method required very less temperature. Less temperature means it required a liquid nitrogen or something, liquid helium to cool down this thing to make this complexes. That's why this method is expensive. Also, this vapor diffusion or vapor condensation method gives the lesser yield of the complexes, or sometimes complex at the low temperature it may be stable, but when it go to the little bit higher temperature, sometimes it decomposes. That's why this method is not suitable for making this type of thing. See, here you can, whatever I am discussing, we have ZrCl4. ZrCl4 means zirconium in plus
Zirconium
4,
tetrachlorate. Yes, that
plus
is
per
good.
fluoro per plus 4 oxidation state. So what will happen? So what is the role of this?
So this is actually a reducing
So
agent.
this is a reducing agent. This
Yes.
reducing agent will reduce the zirconium to 0 and it will bind to the olefin. Okay,
Yes, sir. Yes, sir.
this we have already seen. This is from the introduction, from the application and introduction. So we move that question, that aluminium AlR3, that is also a preparative method for synthesizing the olefin complexes. Just let me find out. And here we have also discussed this question. Here you can see when this reacts in excess of ethylene.
Okay.
So which is
Yes, sir.
stable.
One is ethylene, one is cyclotetraoctane.
So and this is only stable on this condition, and this one is only stable at 0 degree. Above 0
Yes,
it
sir.
decomposes.
Freezing temperature.
Above 0, up to 0 degree it is stable. So above 0 it decomposes.
Yes, sir.
we are all discussed. I have discussed everything. This is the bonding. So bonding, let me show the thing. Mm. Here you can see. So when we have a diolefin like butadiene or something, so here the psi 1 of the ligand, psi 1 of the ligand, and these three orbital of the metal are suitable for the sigma bond formation. So with the psi 1 of the ligand and with the pz orbital, that is from the p contribution, and d z square orbital, and this form the sigma bond. Whereas pi bond, we have py and px orbital from the pi bond, and d orbital of the metal, that is dyz এবং dxz, these two from the pi bond. Whereas sigma bond can be formed, or you can say the delta bond can be formed from the dxz orbital. Okay.
Yes, sir, fine.
You got the logic? Because why it is forming? Because this should match the symmetry. This should match the symmetry. So s orbital is totally symmetric, so it will interact. Pz orbital is symmetric, it can interact, and this also symmetric, so this can interact. Whereas if the symmetry break or it have only one node, then it can be this. And py also, and here we consider one orbital, which I explained in the last day also, that one orbital we have to choose the which orbital we are considering as a bonding axis or internuclear axis. So dyz and dxz from the pi bond. And coming to the last lecture, we have seen the metal diolefins, that is, and the conjugated olefins. So here you can see the electron excitation. That means when the metal gives electron to the pi star orbital of the ethylene moiety, what will happen? This will go to the higher energy orbital, and because of this it will lengthening the terminal CC bond and shortening the internal CC bond. So when the electron goes to the pi star orbital or higher energy orbital, it will decrease the CC, it is bond strength, that means the bond length will increase. So we have continued our discussion in the last week, that is in the week 12, and that will be held on next Saturday. Okay.
Yes, sir. Next Saturday the session will happen.
Next Saturday we will have a session. Next Saturday is, what is the date? I think 11. I think 11. Yes, next Saturday
Yes, sir. 11th.
11. So next Saturday we will discuss the last step is that will be diolefin complex and conjugated and unconjugated fashion, which will be the last session for week 12 content, as week 12 content is already live. So that
Yes,
will
sir.
be last session, and the next Sunday, that is 12 of October, will be the last session as an interactive session for this course. So if overall doubt from all over this course, you can discuss in this 12th. 12 in the 12th, that is October 12th, there will be no question answer discussion. We will just go through, browse this book, and will be just to summarize, or we will give you the overall idea of this overall content of this course.
Yes, sir.
That may be a summarization of the course. Okay, so better, so to on the 12th October, that is the next Sunday, you come prepare with the sum of the doubt or any doubt from this course, or if you have any kind of thing from this course you want to ask related to this topic, we can discuss that. We can discuss in on Saturday also, so that if anything goes wrong or if anything not possible to discuss instantly, we have another time of the next day to discuss. So after 12 October there will be no session from my side. Okay.
Okay, sir.
Okay, then I'll stop it within few minutes.
Okay, sir. Thank you very much.
See you in the Saturday.
Yes, sir. Sure. I also sent it mail to the NPTEL people. Okay, that about the hall ticket issue.
Today is Sunday, so tomorrow there will be a Monday. So Monday they will reply.
Yes, sir.
Okay then. Thank you.
Yes, sir. Sure. Thank you very much, sir.
Okay. So with this, we have successfully completed the interactive session of the week 11 content, that is the metal diolefin complexes, their reaction, their properties, their bonding, and their reactivity. So next week we will going to move the last session of this that is week 12 content, and we will move to the another system, that is the diolefin or conjugated diolefin system. So I hope this lecture series or this problem solving series, better to say, will be helpful for better understanding the content of the course, and it will be helpful to solve the problem in the exam as well as the portal assignment. If you still, we have 2 more days. If you have any doubt, you can directly join in the two session, that is the Saturday and Sunday. Next Saturday and Sunday, it is 11 and 12 October. Timing is the same for 4 to 6 to get your doubt cleared, and after that there will be no live session from my side. Still, if you have any doubt, you can email me. The contact email address given in the portal in the drive assignment sheet. So you can send me. I will try to reply as quickly as possible. It's only for the my question part. So if you have any doubt from the portal assignment or exam related issue or technical issue, you can put your doubt in the discussion forum or directly mail the NPTEL support team, so that they will help you during help you regarding this technical thing. So with that, I concluded the today's session, and we will see you in the next Saturday for discussing the last week content, that is the week 12 content, and then 12 will be a summary session where I will discuss the different or discuss the summarize all over the course and give a brief overview of the course. If you have any doubt till then, you can also discuss in that day. Okay, then thank you. See you on the next Saturday. Another thing is, whoever watching this session from the YouTube, I asked them, please join in the live session and get your doubt cleared. uh, and it would be better if you interact or discuss the thing, or if you any thing, or if you are facing any kind of problem, if you face any kind of problem, that you can also discuss. I hope this is all from my side. Hope we could see you in the next day. Thank you.